Next, we're going to go into FDD, fault detection and diagnostics. So with this, what we're really doing is pulling in data over a BMS system. And so the way which we can get data in is a number of different ways. You can see we can pull back nets over IP. We can do it over Niagara. We can do it Modbus TCP, MQTT, database for older systems where we have a SQL Server database as an example, and over REST API. And when we pull that data in, what happens is within the BMS discovery, I can go protocol discovery, bring this data in, and then we see a station list. So here we can see we have a number of different folders within the station. And we can see we have boiler house, roof plant room, energy meters. And what we can see here, if I go into the point list, across those folders, this is telling us all of the available points that we can pull in to the system. And that's a really important part, which we'll go into as to why that is the case. And so what's really powerful here is if I have a sub-meter as part of a BMS system, you know, I can select that as a sub-meter, register that as a meter, and then, you know, what floor it's on, the utility type, register that as a meter, and then that would show us a sub-meter as part of the main energy monitoring. So we don't just need to take energy meters from suppliers, we can also take it directly from BMS systems as well. The reason this is important is because once we get that data, we can do really smart things, like we can create relationship maps based upon parent-child relationships. So in this instance, what we're looking at is we've extracted data from a BMS system and then using nothing more than connecting these data points, so creating that parent-child relationship. The reason it's so important is for root cause analysis. What we want to be able to do is in split seconds, not in days or hours, is be able to quickly have our system review and provide us an analysis based upon what it's seeing. And so here you can see right now we've created that parent-child relationship. So we have chiller 1, chiller 2. The children of those are coolant tower, chill water pump 2, chill water pump 1. And then the children of these are things like your AHU, your VAVs, your fan coil units, your kind of end terminal units that would be considered on a chain between parent-child relationships. And again, for root cause analysis, our FDD system has a load of rules that we've created that are mechanically based rules that takes a snapshot at every moment in time whenever a rule gets broken to provide that analysis in seconds. As I say, you know, a typical engineer might, it's really warm in an office, get a call out, engineer comes to site, first thing he does, pops his head above the ceiling, checks valves, or maybe on a fan coil unit, sees the valves are operating okay, sees the fans running okay, then has to go and maybe check that there's a zone valve somewhere in the ceiling, he's moving his ladders. He then figures all of this out from kind of endpoint all the way back to root cause, which might be, you know, a valve, a 3-port valve that's maybe stuck in a plant room or whatever it would be. What we do is we take a snapshot instantly and we have our Ask Apex do the analysis straight away, and it provides a lot more context to that data, which we're going to show you in a short while as you continue seeing that. So really powerful relationship map that we create. But then kind of the key to this, go back to a different build in a second, is obviously we're creating this data, we're pulling this information in. You know, we can look at the trends, we can look at all of the different things over the last 24 hours or last hour or last 7 days, but it's surface level stuff, right? Really what we want to be able to do is really get a deep understanding of what's going on within the system. And that's where we come into our FDD. So